Hello friends, welcome to Shiksharthi. In this video, we'll be talking about quadratic equations. So let's start. Initially, we start off with the discussion of roots and then we end on what is the final condition for real roots. Before I begin, I would suggest that you should watch my earlier videos, the previous videos that I have done on quadratic equations and expressions, because all of them are interlinked. In today's session, we'll be talking about the conditions of real roots ending on a delta, which is the discriminant. We are not starting off with a delta, which is generally used. So I would suggest that you watch right from the beginning to the end, talking about all the videos, so that you are able to have a comprehensive view of the topic, because you will not get this discussion elsewhere. Yeah? Okay. So now when I say that this is a quadratic equation, given that a is not equal to 0, and I am saying alpha and beta are the roots of this quadratic equation. So as discussed in my previous video on quadratic equations, the roots may be real or imaginary, and then we talked about how many real roots and the authenticity of the cases that we had made. For example, I can have 0 real roots along with 2 imaginary roots, and at the same time I can have a maximum of 2 real roots along with imaginary. I cannot have a condition wherein I am having 1 real root and 1 imaginary root, right? So now, further segmenting this discussion, what I can do here is, this discussion can be divided into 2 parts based on the magnitude. Magnitude means we are talking about the value of both the roots being same, and at the same time we are talking about the values of both the roots not being the same. And these are those cases which I have already discussed in the earlier videos. Now what I am doing basically is, which we had done earlier also, but here also what I am doing is, when do I say that both the roots would be equal? When do I say this? So we start this discussion with the discussion on polarity. I can say that for both the roots to be equal, right? For both the roots to be equal, their polarities need to be the same. Now when I say their polarities need to be the same, means what? If this is positive, this also needs to be positive. If this is negative, negative, 0 and 0. At the same time, their magnitude, their value also needs to be equal. So how many cases can I get here? 1, 2, 3. 3 cases I can get. Then the second condition which comes up here is, I know that real roots and imaginary roots in a quadratic equation, they cannot coexist, right? So when I'm talking about 2 roots being equal, either I talk about both the roots being imaginary, right? Or I talk about both the roots being real. But we know that imaginary roots, they exist in pairs, and the pairs are what? A plus IB and A minus IB, right? So now both the roots cannot be equal. So the condition of 2 equal roots, just by mere reasoning, will come only under the head of real roots. I hope you understood it. Now the moment we are able to establish the fact that the condition of 2 equal roots comes under the head of real roots only, then we can further segment them into rational roots and irrational roots, the cases of which I have already discussed here in detail. I'm not going to discuss this here. This is for your reference. Now when you sit down, you can re-watch the video and you can find out why are these cases made. So when I say that there are 5 cases that I have made, what I intend to say here is, I have given the values. So what I basically am saying here is 5 cases. This is the first case. We're talking about 2 real roots and both the roots being equal, right? So either it will be an integer along with another integer, I is for an integer, or I will get 2 equal roots wherein one of them is a recurring decimal and the other is a recurring decimal. So please relate the recurring decimal discussion I have done here. I have taken both the examples. So here I am giving you a broad view, and here I have already given you a micro view, a micro analysis, right? At the same time, one of the root can be a terminating decimal and the other root also needs to be a terminating decimal, and both the values should be equal. For example, if I say this is plus 1 by 2, this also should be plus 1 by 2. At the same time, this can be minus 1 by 2, or this can also be minus 1 by 2. Similarly, if this one of the root is a surd, the other root also should be an equal surd when it comes to magnitude and the polarity as well, because we are talking about real roots. Last but not the least, we are talking about special cases. What is n? Neither terminating nor recurring decimals. For example, if I talk about pi or e, this is the last case that we have talked about. Now when I club all these three cases are the cases for rational roots, which I have already written here, and these two cases are the cases for irrational roots. Now why am I discussing so much, and why am I requesting you again and again that this is really important, this reasoning is really important? Because as we go in higher order equations or equations having a higher degree, it becomes very difficult for you to understand all these things. So it is only when the calculations are lesser, I mean, please try and understand it in terms of calculations. So a smaller calculation, I will be able to understand it more because I'll be able to practice it more and I'll be able to understand it at the same time. But if I give you a 4-digit number to be multiplied with a 4-digit number, the calculation itself becomes quite exhaustive, what to say of understanding. And generally it is seen that exhaustion reduces the level of understanding. So when I am not discussing, when we are not doing something comprehensive, in smaller order things only, try and discuss, because this entire discussion is going to help you in cubic equations and polynomial equations as well. Right, coming back. So now this was the case wherein two roots are equal. So when two roots are equal, I am just giving a recap. Two roots, equal roots are possible only in case of real roots, which we reasoned few minutes back. Taking this discussion forward here. Now when we know that two roots are equal, and in my previous videos on quadratic expressions and equations, we have already discussed that these are the values of the roots. When I equate these values, I get the value of delta is equal to 0. So what did we discuss? We will finally end on, we never started off with delta. I could have started this entire discussion that delta is equal to 0 means real roots. We started it the other way, which is the converse of that. Right? So we end on what? If delta is equal to 0, that means real roots and equal roots. So the condition of two equal roots and real roots means what? Delta should be equal to 0. Which means that when delta is not equal to 0, should be a condition for non-real roots. Please recall my video on reasoning, I mean understanding inequalities with the help of reasoning. Please refer to that video, in which I have already talked about not equal to 0 means what? Either greater than or lesser than. Not greater than means what? Equal to or lesser than, etc. Please refer to that video, that will help you to reason out the things here. Okay, so when I know that delta is equal to 0 is the condition for real roots, that means what? Delta non-zero is the condition for non-real roots. But when I segment this, because I know delta not being equal to 0 means what? Either delta is less than 0 or greater than 0. So I have to choose one between them, which we'll talk about in the subsequent videos. What exactly is the condition? Now one condition between them is the condition for non-real, which means imaginary, and the other one in any case becomes the condition for real roots. Right? Last but not the least. Now when both the roots are not equal, then the roots may be real and imaginary both. I mean, these are the two conditions, either two real roots or I will have two imaginary roots. Now when I am having real roots, now here I know that both the roots are not equal. How many cases will I get? Just to give you a hint. It is just like saying, and you get the hint from here, one integer root, another integer root, and they may not be equal. I have already taken the examples here. So there is nothing that I am discussing here which I have not put on the board here. I am talking about when there are two roots which are not equal, how can what are the cases that I can take? I mean, either I'll take both of them as integers but not equal, or I take one of them to be an integer and other as something. So from here I could have said, along with an integer, how many other cases that I could have taken for the other root? 1, 2, 3, 4, 5 cases. Now if I take one of them as recurring decimal, what are the other cases that I can take? I can take the other also as a recurring decimal, 1, 2, 3, 4. With a terminating decimal, how many cases can I take? 3 with surds and with this. So the total number of cases would be how many? Can I say 15 cases? Yes. So just give this a rethought. And this element of reasoning in mathematics is going to, create wonders for you when it comes to substantial learning. Okay. So if you think that something different has been discussed today, please do not forget to like, share and subscribe to our channel. And if you have already done so, please click on the bell icon and select the button all. Right? Thank you so much. Until next time we meet. Goodbye.